All right, so to start this unit, we need to talk about functions and function terminology. So throughout this unit, we are going to be using these words interchangeably. So these words are all synonyms. So the word input, independent variable, and X can all be used to describe the same thing. Same thing with the word output, dependent variable, and Y. So it's really important to know that these three pairs of words mean the same thing. So a relation is any pairing of an input or an X value with an output or a Y value. And it can be represented 5 different ways. It can be represented as a table, as a graph, as an equation, as a mapping diagram, and as a set of coordinates. So let's take a look at just one example. So here are our 5 ways. Here's the first way, as a set of coordinates. So the point -1, -2, 0, -3, 1, -2, 2, 1, 3, 6, 4, 13. So this is a relation because you have your input and your output, or your X and your Y for each of these points. The second way was as a graph. So we can see the point -1, -2, 0, -3, 1, -2, and so on. So we have the points from our relation represented on the graph. We also have a table, which basically just took all of these values and took the X coordinates and put them in the X column, and then it took the Y coordinates and matched them up into the Y column. So for instance, the point -1, -2 is right here, -1 is the X, -2 is the Y. The mapping diagram is probably the newest one to us, and all that does is it takes the X value and it draws an arrow to its matching Y value. So you have your inputs on this side and your outputs on this side. Another example, 0 was matched up with -3. So the diagram just shows us what each input is matched with. And then the fifth way is as an equation. So they told us here what the X values were. These were just straight from our table. And if we were to plug each X value into the equation, we would get out the matching Y value. So the equation can just represent the table by mathematically finding those Y values. So relation is going to be the big category. Functions is going to be a special type of relation. So it's going to be a special category inside of relations. A similar example in math to this diagram would be rectangles as the big category and squares as the smaller category. So you heard growing up, squares are always rectangles, but rectangles are not always squares. It's going to be the same thing here. Functions are going to always be relations because a function is a special type of relation. However, relations are only sometimes a function. So a function is always a relation, but a relation is only sometimes a function. Because the definition of function is a special type of relation where each input has one output. And we say this so much that I actually use an acronym for it. I use EHU, each input has one output, because we say this phrase so much to justify why something is a function. So if we look here, each input, So remember with mapping diagrams, these are our inputs. 1 has 1 output. 2 has 1 output. 3 has 1 output. That makes it a function because each input has only 1 line coming off of it. This one is not a function because if we look at our inputs and our outputs, 2 has 1 output, but 3 has 2 outputs. So this is not a function. This would just be considered a relation. And the vertical line test helps us to determine if a graph is a function or not. And it says that if you can draw a vertical line and it crosses a relation at more than one point, then it is not a function. So for instance, this one would not be a function because essentially the blue line represents inputs. So when I draw the blue line and it crosses twice, that's not Ehu. Each input doesn't have 2 outputs here. The blue line crosses twice. As opposed to this graph, when I draw the blue line, aka the input, it only crosses once. So each input has 1 output. That's the definition of a function. So function notation is what we use to describe functions. So if we think back to our synonyms, input x, independent variable, output y, dependent variable, f of x is another way of saying y. So y equals 2x is the old way we would have said this. This is the new way that we're going to say this. F is the name of the function. X tells you what the input is, and 2x tells you what the function's doing, and it's going to tell you what the output is. So 2x gives you the output. So here, f of -4 means -4 is going into the function. This is the x value. So where I see x, I'm going to put -4 in. So f of -4 is equal to 3 times -4 squared plus 4. And so we have to do PEMDAS, so we have to do -4 squared first, which is 16, times 3, which is 48, plus 4 is 52. So f of -4 is 52. That tells us that the input was -4, the output was 52. For the next one, we're actually plugging in an expression. So we're going to put in 10n. So we're going to do g of 10n, and we're going to replace out this variable with 10n. So we're going to do 5 minus 4, replace that with 10 times n. And 4 times 10n is 40n, so it's 5 minus 40n. That's actually our final answer for this one. G of 10n, when 10n goes in, 5 minus 40n comes out. So just a few more examples that if you have the packet are in there. So to find h of 6, 6 is my input. 6 is going to replace the variable. So h of 6 is equal to the absolute value of 6 plus 2 plus 3. 6 plus 2 is 8, so it's the absolute value of 8 plus 3. And the absolute value of 8 is 8 plus 3 is 11. So h of 6 is equal to 11. When 6 goes in, 11 comes out. Input, output. F of -8, I'm going to replace x with -8. So I actually have to put it into 2 places. So f of -8 is equal to, in parentheses, -8 squared. Whenever I plug in, I always like to use parentheses so that I can see that I'm squaring a negative number. So -8 squared is positive 64, minus 3 times -8, that turns to plus 24, which is 88. So f of -8 is equal to positive 88. Negative 8 went in, positive 88 came out. And then here I'm going to put x plus 2 in for x. So h of x plus 2 is equal to 4 times x plus 2 minus 2, which I distribute my 4 to get 4x plus 8 minus 2. And when I combine my like terms, my final answer here isn't a number, it's an expression. So when I plugged in x plus 2, the expression that I got out was 4x plus 6. Same thing here. I'm going to plug in anywhere I see the variable, negative 4n. So g of negative 4n is negative 4n to the third minus 5 times negative 4n to the second. And so when you cube something, remember you have to cube each portion. So I'm cubing the negative 4 to the third power is 64. I'm cubing the n, which is n cubed. Same thing here. Negative 4 squared is 16. N squared is n squared. And I have to multiply that by negative 5. So if I have negative 5 times the 16 that I get here, that gives me 80. So it's 80 n squared. So when I plug in negative 4n, the expression that I get out of my function is negative 64 n cubed plus 80 n squared. So then we have the vocab words domain and range. Domain are the set of input values and range are the set of output values. So in this function, my input values are 0, 3, negative 3, and 2. Notice that they don't have to be written in order. So it's okay that the negative 3 comes after the positive 3. That's okay. And then the outputs are 2, 4, negative 2, and 4. Notice how I don't write the 4 2 times. You only write each number once. You don't repeat numbers. So order doesn't matter and don't repeat numbers with domain and range. And then we have function notation in real life scenarios. So a of h, and this is the way we say this, a of h. That's how we say that. Equals 10h plus 20. A is representing how much money you have. H is representing how many hours you work. So A of 2 equals 40 tells me that 2 was my input, 40 was my output. So 2 is how many hours I worked. So I worked 2 hours and my output is the amount of money I have. So I have $40. So input here, input in this case was the number of hours, output here was the amount of money that I had. And then so for this function, my input is the period. The output is the room number that I go to. So F is assigning the period in your schedule to a room number. So F of 4 is what room do I go to? Period 4. And then F of P is 107. 107 is the output. So that's, in this case, the room number. So this is kind of saying, what period am I in room 177? F of negative 6 is the input. That doesn't make sense because there are no negative periods. And F of 200 also really doesn't make sense because hopefully you don't have 200 classes in your schedule. That'd be kind of crazy. So no, because there are only 8 periods in a day.